Sorry, that got cut out for some reason. So in terms of our vernier computers, you're going to want to plug in the CO2 probe, and you're going to want to plug in the temperature probe. When we look at these bad boys, I know this is in reverse. This is 21.7 degrees Celsius. I believe that number. That's about 65 degrees Fahrenheit. When I look at this probe, it's 314. I believe that. We want it to be in the mid 300s. If your probe is acting wonky and giving you a number that you do not like, put the probe in this biochamber. Do this every single time. Make sure the setting is not on high but low. And then you can press the cal button until the thing should go red, and then it will blink green. If it's blinking green like this, it means it is not ready to capture data. One of the best ways to get bad data in this experiment is by collecting data when it's flashing green. It's now solid green, so we can collect the data. You're going to want to make sure that you write down what the starting ppm on this is when you collect. So, to collect the temperature data, you're just going to look at this before you collect and just look at how your screen changes. You can do this when you're finished as well. In terms of the settings for our computer, I believe we're going to go here. And we are going to be changing. Let me look at our methodology. We're going to be collecting data for I'm looking at it right now. Right, 5 minutes. And we want to be taking, how many samples per minute? 20. The rate is 20. When I do that, the magic number that you should always see at the bottom here is 101 data points. That should give us a good balance of accuracy and precision. So when I'm ready, my yeast is all good to go, and this is not good to go. We need to wait 3 minutes. We should see some bubbling. This is not great. If you have questions about your yeast before you put it in, let me know. I'm going to pour in. Now it's really important that you, get as much of your yeast in as possible. So notice the beaker, there's a lot of yeast in it. That looks pretty bad in terms of a mixed job. I also want to make sure when I pour into the biochamber, I get nothing on here. Now, looking at this beaker right now, I can already tell you that I'm going to be changing the methodology to 50 mils because this is too shallow of a volume for the yeast to be always interacting with the surface. But that being said, as soon as you pour it in, put in your biochamber and press collect. And then we wait 5 minutes. And this is a great opportunity for you to be cleaning glassware, for you to be getting the next sample prepared. It's very easy in a group of 3 to 4 to be busting these out, where basically this finishes, you capture some data on your computer, and then you put in the next one. Groups that it worked well have been able to do 7 to 9 of these in a class period and also capture really good data. So as we're capturing our data, we should be seeing things change in terms of our CO2 values. There might be a little bit of lag with that CO2 value, given that there's such a large amount of air and we're really trying to get the air to flow up into these biochamber sensors. It's really important that this does not get wet. One of the best ways to get crap data is to knock this over because you're being foolish or careless, and then the sensor gets wet and all of your data is wrecked. So put this between a textbook and a computer, put it somewhere that's not going to be disturbed. That way your data can be good. Now if I'm looking at this, my computer is not collecting good data. It's stuck at 50 ppm, which tells me that I didn't accurately calibrate my probe beforehand. So never fret if you're collecting data and all of a sudden you recognize that your probe is not doing what the probe should be doing. There's a quick, easy fix, and I'll show you how to do it with the data. Give me 1 second. So I'm gonna gently, with my probe, press the cal button. It's going red, and now it's going green. My probe now is at 409 instead of 50. And if I watch it for the next couple seconds, it should start to go up if the yeast is doing their job. And it indeed is. I'm now at 413. I'm going to wait another data collection. It's going up. Excellent. So when it comes to that, there's an easy way to select the data that we actually want if you start off an experiment or end your experiment with crap data. Do not fret. I will show you all. So I'm going to press stop with my experiment and show you how to get the data. So I'm going to press stop. I'm going to take this probe out. I'm going to wipe it with a paper towel to make sure it's dry. I'm going to get my final temperature recording. To do that, I would lean this over and press it into the base of the fluid. To do that, you're going to go back here on this probe, and this will then show you the live data so you could see that. You're just going to be, again, pressing that little time signature. Now, in terms of my data, I want to get the following things. I'm going to go to Analyze. I'm going to go to Curve Fit, and I'm going to press, so again, I'm going to press Analyze, Curve Fit. Actually, this would be better. Analyze, Curve Fit, and I'm going to press CO2. This is for a linear trend line. I have my M, which is my slope, and I have my RISME, which I also want to get. I have my correlation, or R squared, at 0.083. So those are data points you're going to be putting in here. Now, this is for data that started bad and is now doing better. I don't want that. So I'm going to press cancel. I'm going to go back to my data, and what I'm going to do is with my finger clicking and dragging, I'm going to highlight. I'll show that again. I'm going to highlight the data that was good. And then I'm going to press Analyze, Curve Fit, CO2. Now it's only doing an analysis of the line for the data I selected. My slope is different. My RISME is a lot lower. My correlation is much better. So again, I'll show that again. I'm going to click and drag the data that I want to select, and then press Analyze, press Curve Fit, press CO2, and this is it. I can see if a different one gives me a better RISME or a better correlation. I could go to, for example, quadratic, but I think most of you are going to want to stick to linear. So again, in a nutshell, that is the experiment. You're going to want to rinse this out and hang it to dry for the next class. Your glassware is going to want to be cleaned. Your CO2 probe and your temperature probe need to be wiped off with a paper towel. This needs to be immaculately cleaned. We can't have yeast and sugar all over the place. And yeah, that's the experiment in a nutshell. Helpful? Please watch this before class, and that way you can get a head start on your experiment. Bye for now.